Alright, how you doing? Welcome back to the next video on the Soldiers of Fortune 2 Unreal Edition series. In this one, not too much to show you within the game because I've been working behind the scenes, updating the code, redoing it, overhauling it, as I said I was going to do in the last video, and that doesn't really change anything to look at the game. There is a lot of work there to do, and that's going to be an ongoing process. But I've had a bit of an idea I'd like to run by you. So, if we go into the game, as you can see I'm tidying things up, but if we go into the game and start it, I want to show you something. So I have spoken about, I'll come back out for a second, I've spoken about a group of people who took the OpenJK source code that was released by IOpenSoft and attempted to make SoF2 in it. It's called OpenSoF2MP. And as you can see in the images on their website, they got quite far, they got the level loaded, that sort of thing, but they stopped in 2014 and they haven't taken it much further. So I downloaded that, and I've been looking at that as a way to understand SoF2, how the code works, and all that sort of stuff, all that sort of stuff, because I hope, kind of believe, but hope that IOpenSoft will release the SoF2 source code at some point. And if they do, I could add that to the game. So that's kind of the idea that I've had. What I want to do is incorporate the SoF2 source code into SoF2 Unreal Edition as a component of the game, as part of the game. I could actually do it with the compiled binaries, the executables, but I would prefer to do it with the source code should they ever release it. So I'll show you what I mean. So this is SoF2 Unreal Edition as you've seen before. If we go to here, this button here I've linked up, I'll show you quickly. When I press that button, it's going to start the SoF2 exe that has been made from the OpenJK source code using create process, and it's going to be displayed as separate process but as part of SoF2 Unreal Edition. So if I press it, you'll notice the console doesn't open because I've changed the code so it hides the create process. I've changed the code so it hides the console, but it does open the actual game. And what I've decided I could do, see, this isn't SoF2, this is OpenJK source code modified to run SoF2. And what I decided I could do is I could take that image there, port that from the game to an Unreal Engine render target, and I could do that from the executable. But as a kind of a hack, if I could get the SoF2 source code, I could go into the source code, and I'll show you what I mean in a second in the OpenSoF2MP code. I could port using render targets the output from SoF2, the original SoF2, to an Unreal Edition render target and have it as a component of the game. So the UI in this works, but when you start a game it actually crashes out. So that's that's not my game, that's the OpenSoF2 source code that does it. It starts up and then it crashes out. But the point is, I could add the original source code as a component of the game, and that would make it completely backwards compatible because it is the actual game. And then it crashes out. So let me show you what I mean. So it runs the exe there, and if I had to do it using the compiled binaries, I could simply take the output from that window, don't display the window, hide the window, but take the output from the window and show it in a Unreal Engine render target. But what I would actually like to do, if I close that, is what I've been working on is compiling OpenSoF2 as x64. It's a 32-bit code initially, but compiling it as 64-bit and then adding it as a static library or a dynamic library to my game. And then I could go into, I found where the game is rendered to the screen. It's in tr_scene there. So somewhere in here, if I just type in render, add reference entity to the screen. Where is it? There you go, render scene. render world effects, render automap, render scenes. So there's 3 render functions that run to render the game to the screen, and all I would do is add a second component that renders to where I would want it to go, the Unreal Engine render target. So the game would run, the original SoF2 would run as a component, a separate component of my game, rendered to a render target in Unreal Engine. And I thought that's quite a good idea, that's quite interesting. But it's not quite as straightforward as you might think. As I say, the code was originally written as x86 32-bit, and to convert it to x64 has been a little bit difficult. I will confess, but I have managed to compile it as x64, and it's a step-by-step process to get it to work under 64-bit, as a 64-bit application. So that's the idea I've had, and I'm pretty much convinced it's going to work. But what I'm going to do now is I'm going to take you through the whole process of converting it from x86 to x64 and show you exactly what happens. So anyone who works with the OpenJK source code could use this process to compile OpenJK as x64-bit if that's something you're interested in. I will say I'm not an expert in C++ programming, so the way I do it is the way I see it working. It might not be the best way to do it, but you're welcome to watch and take it on yourself and do it yourself. So what I've got here is the one I've been working on, and I'll show you where you can get the OpenSoF2 source code. OMG, WTF, lol.rivercrew.net, and they've got a link to get their GitHub page there. And the one I've used, there's another one, there's 2-3 forks of it, and one's like 4 commits ahead, so I'm using that one just now, but they're both pretty much the same. You get the source code, you extract it, and this is what you're given here. The solution file we want is into code MP, and it's SoF2MP VCX PROJ for Visual Studio C++ project. So we open that. It's going to ask us to upgrade it to the latest version of the Windows SDK, which we will accept. This is going to be quite a lengthy process, so now that you understand the idea of having the original code running as a component of my game, that's the idea. The rest of this video, and it might be quite long, is me just showing you how to do it. So it didn't ask me to upgrade there to the latest version of Windows SDK because I've already done it. So in fact, I might have cancelled it. I'll just check. Go to solution and retarget solution and just hit OK. And that's it done. So first thing we want to do is set up the configuration manager to have x64 as an option because it's not there. I won't do debug, I'll do release because they're pretty much the same. There's a couple of things in the debug that are specific to debug, but I use the game as release, so I'll just do it as that just now. And we'll go to configuration manager, right click on the platform for RD/vanilla, new, x86, copy settings from Win32 and create new solution platform. And for SoF2MP it's new, x64, and untick that box because it already exists. And that is the configuration manager set up to compile for x64. So first of all, we will build it as x86 32-bit because we wanted to be able to build both. There's a few errors to fix on x86, so get it working there. Then we change to x64. So build solution. So build failed, 759 errors, but there's really only one fix for each one. There's a multiple fixes, but it's the same one. So go into each of the files, and if you notice, they're all errors on the string type. So what we do is we go up to the top and we just make sure that we have hash includes, right, angular brackets and just string. Just make sure that's in each of these files. So rm_path, their objective, instance. Pretty sure that's the one. So we'll build again. Yeah, so some of them have, if not defined Win32, then include that. We just want to comment that out. Come on. Comment that out and then make sure it's defined no matter what. So that's rm_path. And then it's there. Task manager.h. If there's more than one include, we'll just comment out the one we are interested in. So that's snd_music, snd_mem, both.cpp. Task manager we've done, task manager.h we've done, and we shall compile again. And build succeeded this time. So that's it compiled under x86, and we'll just check to make sure that it works. Come on. So, alright, it's working, but it's looking for the base folder, which I haven't put in there. So, SoF2 base folder. Now, where did I put it? Where is it in this? Okay. And so there is OpenSoF2MP, SoF2 remade, or an attempt to remake SoF2 in OpenJK source code. And it's working exactly as it was I showed you a minute ago, except it will crash out here or it gives you this error. So anyway, that it is working there. The code goes as far as as it can go, but the code is working there. So it's working on it. It's compiled in x86. We now want to change it to compile on x64. So we've created the option for it in the configuration manager. We just changed to x64 and we build. So on its first attempt, 4,356 errors. There is one change that I've made that I haven't mentioned. It's in the q_shared.h up top, and it is, okay, I'll just search architecture not supported. So line 411 in q_shared.h, you just comment out that line. That's a preprocessor error put in by the developers to make sure it doesn't run in x64. That's the first thing that comes out. The vast majority of errors are for inline assembly, which x86 C++ supports, but x64 does not. So what we have to do is we take the assembly out, we put it in a separate assembler file, and we compile it that way. So I've done that. I haven't fully tested the code, but it compiles. Most of the code is for in-game stuff rather than loading of the game, so I haven't been able to test it, but it compiles and works, so that's fine. So, where are we? In SoF2MP, we create a file called asmprocs as in procs.asm. I'll just copy all that in. So into soft, add new item, asmprocs.asm, and that's all the code. They'll show you the code in a second. There's a couple of things we need to do first of all. Where do you do this again? Right click on the project, SoF2MP, build dependencies, build customizations, and you tick MASM targets props to make sure it compiles assembler. You go right click on the file you just created, asmprocs.asm, and change item type from does not participate in build to, where are we? Microsoft Micro Assembler. And that's that. So the actual file, there's 5 or 6, I don't know, maybe 7 or 8 functions. All I've done is taken the function from the original code and put ASM in front of it. So anything with a semicolon in front of it is a comment. You've got option case map :none dot code as the start of the code, and I'll slowly just scroll through the file and let you see the code. So the first one is ASM vector to int. Second one is ASM snap vector FLD. FLD is a load integer into the FPU, the floating point processing unit. Next one is snap vector FISTP, which is take it back out. Next one is snap vector FLD1. I needed 2 different functions that do the same thing. Next one is FISTP1, same idea but for the other function. Next one is ASM timing start. Next one is ASM timing end. Next one is ASM call. Next one is ASM call to. Next one is ASM VM underscore call compiled. The push AD function does not exist in x86 assembler, so you have to push all registers independently, so that's why that's there. And then pop. That should all be pop actually. I'll put push twice. That's interesting. I've just copied and pasted that and not bothered and I forgot to change it. Last is ASM com underscore error 1. And then the end of the code. So I'm going to quickly put that into the other source code. Okay, so that's the assembler file, and that should compile. So we will build this and oh no, you have to change obviously the function in the code. So anywhere where you have assembler, so q underscore shared, what you do is you comment out the entire function. What's that snap vector? I'll just show you what I've done. And yep, snap underscore vector. Let's spell that wrong. So there you go. You have to declare an external C function above where you're going to use it. So that's line 1098 in q underscore shared.h 1098. Just copy them in, and then I've kept the original code but commented it and just applied the new function, and it's int x64 underscore t to make sure that it's a 8-bit value passed in, a q word, not a d word. So what I'll do is I'll just copy the entire code from that function. There we go, and that's that one done. And I'll just show you the code as it's compiling. So the code is exactly the same, except I've commented out the underscore assembly in line assembly lines and just added in the functions that I've created. So that's the code there for that one. So next, after it's compiled again, we have this error here, cannot convert from int cdecl blah blah blah. You just double click on that and you change, this as win underscore qgl.cpp line 3520. You change int to int64 underscore t. Okay, so next error down is another assembly function, and this is ASM call. So just do a wee. So line 95, I've added 2 extern function declarations, and then into the function itself. So in the same file at line 145, I've got ASM called 2 as well. XTMP is not appearing, is not declared. So let's see what that is. So XTMP is just a size that I needed to put in manually, and it's that line there under underscore 132. So another quick build. It does get quite complicated, but it does work, so it's okay. So still 400 errors, we'll just take the next one down. Arch underscore string is an undeclared identifier. All these undeclared identifiers happen because I've missed a section in q underscore shared. So go to the top of q underscore shared and then come down to line 156, and you add on to that line or defined win64. Yes, we get that. So another build. Okay, 2 errors. Just take the next one down. It's just another assembler function that needs to be redone. So what one's this? Call compiled. So back into my other code. ASM call compiled. So the external declaration is that there, and that goes on line 1094. just above the function call. I'll put that in the right place. No, outside DLL. Okay. And then the actual source is just that section there. So the original function commented out, and then the new function call with the parameters as 64-bit integers as before, inside that section there. And there we go. I'm going to put, and then build again. $380 errors now. So next one in. Okay. So this one here, if not defined underscore m underscore ix86, just means is about x86. So we just add in the equivalent for x64. So that's tr underscore build2 line 4191. So just put in the new one. Oh, I will keep the original code. And put in the new one. Here's another assembler function. Timing start. So timing.h line 17. Timing.h. Two external functions to go in here. Declarations, ASM timing start and ASM timing end, going at line 6. Right there. And then that function, start, comment out the old function and put in the new call, as you can see there. So comment out the old one and put in a new function call, and it will be the same for end, new function call, comment out the old one. And there you go. So build again. Okay, 237 errors, that is decreasing as you can see. Same idea here. Comment out the old line. Is it that? So build again. Next one should be the same again. If not defined, underscore m underscore x64. Comment out the old one. Build. So what's going on here? Same again. Build again. 179 errors. Right, I think that bracket there needs to come out, I think. So that bracket there at 1150 on VM underscore x86.cpp has to be commented out. Save and build again. 163 errors. Here's another. If not defined, underscore m underscore x64 and build. Sorry, I did that very wrong here. So there's another one there. If not defined, what hash underscore m underscore x64, and there we go, and build. Another one, so that's tr model underscore model.cpp line 681. And build. Another one, tr underscore model.cpp line 932. If not defined, underscore m underscore x64 and build. More assembler. Snap. This is the snap vector function. This is win underscore share.cpp line 50. Two functions to add in. Two function declarations. There we go. And then it's the same code except the assembler component is commented out and the new function added in, so the code is exactly the same. And build. Well, there's the vector2int function, so we'll do that just now. So this is fx primitives.cpp line 423. Okay, that must be, that's it. Here's the function. So fx primitives.cpp line 423, another function, external function call, asm vector2int, and then the actual function code itself is just, is that? Yes, I commented out the entire function and replaced it with that code there. So that to there is commented out and the new function is put in. So build. So 6 errors, down from 4,500, that's not bad. Here's another one of those. Hash if not defined underscore m underscore x64 and build. 2 errors. What is this again? GWL underscore WN window procedure is an undeclared identifier. Did I just add that in? I think I did. So I got the code from the I got the declaration from where it is in the code and just added it in above the line, I think. So this is win underscore syscon.cpp line 385. So there it is, and it's defined here. So if I just go to definition, and I just put that in at the end of the definition at line 28. Yep, just stuck it in there. So build again. Naked unrecognised one error, down from 4,500. We're doing well. So what did I do here? I think I just took this out. I think I just replaced it with that line there. The word naked as a DLL attribute is not used in x86. So I put that in and comment that out. And that's us. So build. Oh, another 6 errors. I don't remember that error coming up, so we'll just take it out just now and we'll see what happens. Build again. Module machine type x64 conflicts with target machine type x86. So what we do here, FX SoF2MP project, go into the properties. Now where is this linker? And all options, and at some point it's going to say machine type x86, I think. Machine x64 there, not that. There it is. So additional options, / machine type, :i386, just delete that. And then build. So we have 28 unresolved externals here, and that's because we are building a 64-bit application, and the original 32-bit used external libraries that were 32-bit, and you can't use those external 32 libraries in an x64 application. So what we need to do now is we need to get those libraries. So into codemp libs Win32, those are the old 32-bit ones there. ALUT is the OpenAL utility, OpenAL32.lib and zlib.lib. So I just typed in zlib binaries into Google and I got the 64-bit version off our website. OpenAL32, you go to openal.org, download the SDK, and the 64-bit library is in there somewhere. And ALUT was a bit more complicated. I had to compile that myself. You just search for ALUT on YouTube, on Google, and there's a, where does that go with that again? I think there's something called free ALUT, and you compile that and it gives you the binaries, I think. I can't remember. Libs Win32. I just get a new folder, call it O32-bit libs. Copy in the 64-bit ones, although they're 64-bit, the naming convention is still the same, so it still looks in the same place with the same file name. And then we build again. And we have one unresolved identifier. Now what was it I did here again? VM underscore x86, and it's F2O, I remember. VM underscore x86, and it's search F2L. That's it there. So line 40 in VM underscore x86. Okay, what did I change here? Did I make it? Yeah, I made a new function. And I just defined it right here. Extern C integer underscore F2L1. I think it's like float to long or something. I can't remember. Takes a float F as a variable. And that's the actual, that's the declaration, and that's the actual definition there. And all it does is returns F cast to a long. So you take that, you take the middle line as well because that's part of it, into the other project, and that's the original code, which we will do that to. Put the new code in, and that should work. And there you go, build succeeded. From 4,500 errors, we got build succeeded on x64. So, as any programmer, any developer will tell you, compilation and a successful build does not mean it's going to work. So, we go into CodeMP. So that's the 32-bit version is put in the build folder there, but in x64, into CodeMP, x64 release, and that's it there. So we start it up. Well, again, it's looking for the, see, it's working, but it's looking for the base folder. So into there, get the base folder. So SoF2UE x64 crashes out. Now what we can do now is we can get out our trusty x64 debugger, and we can open the file we've just created. Now, since I've done this first error, what it is now is just error after error after error that you fix until you get them all working, and most of them are going to be about memory address and the difference between 32-bit and 64-bit. So I know what the error is here because I've already fixed it, and if we go into the code, I just need to remember where it is. Is it this code? Close all tabs. It is the list of files. Every time it reads a file, it moves on 4 bytes. As I said, 4 bytes in 32-bit, 8 bytes in 64-bit. So you just need to change the file. You just need to change the 4 to an 8. So what we'll do here is do an F, and remember what I put in: size of x64 underscore T, which is wrong, but that's what will come up. Should only be 1. Int 64 underscore T, and that's it there. So in the file files underscore pc.cpp line 2307, the function qsort takes 4 variables, the third of which used to be 4, and that's the error. So you can change it to 8, but then it won't work for x86. I did have it as size of x64 underscore T, but that's the same as 8. So what I'll put it as is size of underscore int, so that on 64-bit computers it's 8 bits, and on 32-bit it's 4 bits, and that should then work. So we'll build again, and we'll cancel that just now so it can run. So I might not have built there because I had it open in the, oh, it succeeded. Build succeeded, and then it reads the files and starts up, and then crashes out again for the next error. And the next error has actually been proven to be quite a difficult one. I know what it is. If we start, I've got a breakpoint at a function called cvar_get. It's a very strange the way they've done this. As I say, I'm not a C++ programmer, so this might actually be the norm, but they store the memory address of this particular variable, winvars_tg_we. It's not that one actually. It's glw_state, the OpenGL state of the computer, of the system. Stored as the address of that is going to be stored as a 64-bit variable because it's compiled as 64-bit. But when they use it, they don't use the address. They use this function called cvar_get and save the value as a string, but it only reads the 4 bytes. It's programmed to read 4 bytes, not the full 8. So you only get half. So when it crashes out there, it's because it's only getting half of the memory address. And I can show you what I mean. If we go to we want to go into RD Vanilla, which we're in, search for current module, into modular calls, and we're looking for create window, and if I put a wee breakpoint there, that's it. What are we on? That's fine. So there's create window, and I'll quickly, no, it's not what to do, change my resolution back. So we've stopped on the create window function. So I've narrowed it down to this variable there, glw_state, and what happens, as you can see, it's supposed to, the function there, move this variable into REX, the register REX. It's supposed to have moved the full 8-byte variable, which is a memory address under 64-bit memory addressing system, but it's only moved in 4 bytes. So what I can do there, if you notice, memory addressing seems to be start with 7FF6 or 7FFF. What's that there? Is it FFF? We'll go for FF6. So if I change that value to that, yes, it's the main window procedure we're looking for. It will work, but I also need to go to the place where it gets that value. There, is that correct? And add it in there as well. So it's F6, little ending notation, 7F, and now if I press F9, oh, get past the breakpoints, it moves on. You now get the window displays, and it's crashed. You've got another first chance exception there, but it's moved on from that initial error. So the point is, when you put in the full 8 bits memory addressing, it works. So I know what the error is and I know how to fix it. It's just not going to be particularly easy. Might be quite difficult, that one. So anyway, that is as far as I've got. So after all of that, the point is, if I can get the SoF2 source code, if hopefully Raven soft release it, I can incorporate the original game as a component of Unreal, of the Unreal version, Unreal Edition version, and have it running as a component. So it's so the game will be fully backwards compatible, which is always my intention. Remember, the game was going to be made in 3 stages, and the first stage was to get it looking exactly like the original SoF2 to have that sort of feel and look and make it backwards compatible. So to use the actual game code would achieve that perfectly. And if RavenSoft never release the source code, then that's okay. I can probably do it with the pre-compiled DLLs. But anyway, that is everything I wanted to show you. Adding the original source code as a game component of the new game and port the output from the game, what you see on the screen, to an Unreal Engine render target, and that can be displayed anywhere within the game. So that is that. That was quite a monumental task there. Anyway, so as you can see, there's a lot of work involved, but I don't know if I've mentioned this is a long-term project. So I'm happy to do it, and I'm quite enjoying working on this and moving forward. So that is everything I wanted to show you. I hope I didn't go on too long there. I wanted to show you how to do the process so you could do it yourself, and people who use the OpenJK code can use that to compile it as x64. So anyway, after that, I'm going to go and have a cup of tea. So, thank you for watching, and until next time, see you later.